Hello everyone, in this video we are going to see the Leetcode question number 91, Decode Ways. The question is, you have interpreted a secret message encoded as a string of numbers. The message is decoded via the following mapping. That is, 1 corresponds to A, 2 corresponds to B and so on. Similarly, 25 corresponds to Y and 26 corresponds to Z. And the question says, while decoding the message, you realize that there are many different ways you can decode the message because some codes can be combined with other codes. For example, 2 and 5 or 25. And we are given an example here. If our number is 11106, we can group that as 1, 1, 10 and 6, or we can group that as 11, 10 and 6. The first group corresponds to A, J, F and the second group corresponds to Y, J, F. And the group 1, 11, 06 is invalid because 06 is not a valid code. Only 6 is a valid code. And we are given a note saying that there may be strings that are impossible to decode. Let's see the examples that are given in the question. In the first example, S is 12. So 12 can be decoded as 1, 2 or 12. That is A, B or L respectively. So there are two ways to decode, hence we are returning the output as 2. In the second example, the string is 226. 226 can be decoded as 2, 26 or 26, 2 or 226. So there are three ways to decode, hence we are returning the output as 3. In the next example, the string is 06. So we cannot separate this string as 0 and 6 or 06. Both are invalid. Hence we are returning the output as 0. I hope the question is clear. Now let's see the approach. We are going to solve this using dynamic programming approach. Why dynamic program is best suitable for this type of problems? That is because we have overlapping subproblems. Let's consider that our string is 223. We are dividing this problem into multiple subproblems. That is, first we will find the way to decode an empty string. Next we will find the way to decode the first number. Next we will find the way to decode the first and the second number. Next we will find the way to decode the first, second and the third number. In this example, we are dividing the problem into 4 different subproblems. Based on the first subproblem, we are going to calculate the second subproblem. Based on the second subproblem, we are going to calculate the third subproblem. Based on the third subproblem, we are going to solve the fourth subproblem. Thereby, we will find the solution. Let's take the example S equals to 223. As I mentioned, we will break down into different subproblems. That is, an empty string, the first character which is 2, the first and the second character which is 22, and the 3 characters which is 223. In order to decode an empty string, first we will assign 0 for all the subproblems. In order to decode an empty string, there is only one way. I hope it makes sense. If it is an empty string, there should be only one way to decode. If there is only the first character which is 2, there should be only one way to decode. That is, 2 corresponds to B, which is one way. For 22, there are 2 ways to decode. That is, B, B and V. For 223, there are 3 ways to decode. That is, BBC, VC and BW. Are you seeing any pattern here? 1 plus 1 equals to 2, which is the third subproblem. 1 plus 2 equals to 3. That is the answer to the fourth subproblem. Our answer to this problem is 3. Let's take another example. Our string is 203. So here there are 4 different subproblems. Initially we are assigning 0 for all the subproblems. For an empty string, there should be only one way. For the first character, there should be only one way to decode. For 20, the ones digit is invalid, but the two digits are valid. That is, 0 is invalid, but 20 is valid. If this is the case, we cannot add the previous two subproblems. We have to add only the I minus 2th subproblem. If the ones digit is invalid, we have to add the I minus 2th subproblem, which is 0 plus 1 equals to 1. If you take the fourth subproblem 203, the ones digit is valid, but the two digits, that is 0 and 3, is invalid. If the ones digit is valid and the two digits combined is invalid, we have to add only the I minus 1th subproblem. That is 0 plus 1 equals to 1. So there is only one way to decode 203. Hence we are returning the output as 1. Let's take another example. S equals to 332. In this case, there are 4 different subproblems. Initially, we are assigning 0 for all the subproblems. For empty string, there should be only one way to decode. For the first character, there is only one way to decode. For 33, the ones digit is valid, that is 3 is valid, whereas 33 is not valid because it is greater than 26. If the ones digit is valid, we have to add only the I minus 1, that is the previous subproblem. So for 33, there is one way to decode. For the next subproblem, 2 is valid, whereas 32 is not valid because it is greater than 26. So here we are adding the I minus 1th subproblem. So for 332, there is one way to decode. Hence we are returning the output as 1. Let's see the summary of the approach. First, we are setting the base check. If the string is empty or if the string starts with 0, we are immediately returning 0. That is an invalid start. Next, we are initializing a DP array of size n plus 1. Next, we are initializing d of 0 equals to 1. That is, we have only one way to decode an empty string. Next, we are initializing d of 1 equals to 1, considering the first character as valid. Next, we are looping from index position 2 to n. That is, if the ones digit is between 1 and 9, we are adding dp of I minus 1. If the two digits are valid, that is, if the digits are between 10 and 26, we are also adding I minus 2. At the end, we are returning dp of n, which is the total number of decoding ways. I hope the approach is clear. Now let's get into the implementation. Let's do the implementation. If the string is empty or if the string starts with 0, we can immediately return 0. If not s or s of 0 equals to 0, we can return 0. Return 0. Now we will find the length of our string. N equals to length of s. The length of our DP array is n plus 1 because our first subproblem starts with an empty string. Then the first digit and the second digit and so on. So DP equals to, we are initializing to 0 times n plus 1. At this point, we know that our string doesn't start with 0. If it starts with 0, here we are returning 0. So we know that our string is not starting with 0. So the first character should be a valid number. So we are initializing the base check dp of 0. If it is an empty string, there should be only one possibility. dp of 1 equals to 1. That is, the first character should be a valid character. Next, we are going to iterate from the second index to the end of the list. For I in range of 2, n plus 1. Why we are iterating from the second index? Let's assume that our number is 226. From the second index, the previous number is the ones digit. That is, I minus 1 is the first digit and I minus 2 to I is the 2 digits. 1 digit equals to int of s of I minus 1. Since the numbers are in string, we are converting it to int, and the 2 digit equals to int of s of I minus 2 to I. We are taking the first digit and the 2 digits. If 1 digit is between 1 and 9, we are adding I minus 1 to our DP index. If 1 less than or equal to 1 digit less than or equal to 9, DP of I plus equals to DP of I minus 1. If 2 digits is between 10 and 26, we are adding I minus 2 to our DP index. If 10 less than or equal to 2 digit less than or equal to 26, DP of I plus equals to DP of I minus 2. Now we are going to return the last element of our DP array. Return DP of n. That's pretty much it. Now let's submit it. There is an indentation issue. These two will be inside the for loop. Now let's submit it. The solution got accepted. I hope you like this video and I'm sure that you learned something new today. If you do like this video, please consider to subscribe and I'll see you in yet another interesting Leetcode interview question. Thank you.